Alright, hey everyone. So for this video, what I'm going to do is go over some of the camera collisions that we previously did for 5.3, bringing those into 5.4, and along with a little tidbit of something interesting that I found this weekend on YouTube from Philipp Gehring. I'll post his original video in the description here. And that is being able to have a hot reload functionality within Visual Studio, so that way you don't have to stop your game launcher and compile and then fire game launcher again. So let's take a look at that real quick and see if we can get that going, and then we'll move on to our camera collisions. So first of all, what I'm going to do is let's in my solutions here. So I'm just going to fire this up in Visual Studio, and first of all, I'm just going to be copying and pasting this little code here, in which you guys can pause the video and you can copy that and place it at the same spot in the cmakelist.txt, which is usually at root. So you'll see there's game and there's cmakelist.txt. So go ahead and save that, and then right click on game and build. So once the build completes, you'll be able to reload solution. So go ahead and hit that. So once you have reloaded solution, you can fire up your local Windows debugger. And if you're not sure what's going to fire up when you run this, you can right click on game and go to properties, and under debugging you will see the option they have here. So you can click this drop down. If you want to change that, you can hit edit, or actually, sorry, you can hit browse. No, come on, I wanted to hit browse. So browse, and you can select something else from the list here, which would be sandbox maybe. But I like the launcher because you see what's happening in it. All right, so hit OK, and now let's fire that up. So if we fire up local Windows debugger, you see the launcher is coming up, and you have everything going on. You'll see that I made a quick change to that. If you look at is crouch button pressed, that is blue. So let's go ahead and try and change that to maybe make that black. So I'm just going to Alt Tab out of this, pause the execution, and then go into my player.cpp and change all these values to 0. So I'm going to save, and I'm going to hit continue. So you'll see that it says recompiling, and in Philip's video, this goes a lot faster. I'm not entirely sure how you would, what I might be missing, but now if I go back to here, you'll notice that is button crouch pressed is 0. So that's what we are looking for. And this is, for quick prototyping, for things like this. I've used this heavily when I was trying to do the proper distance of the camera from the player, because I've done some tweaking for that, and that came quite in handy. As you'll see in his video, his compilation is a lot faster, and I'm not entirely sure how that's happening. Maybe I'm just doing the build a little wrong. So if you guys can think of why that might be happening to me, please comment in the video. I'd love to know. Alright, so let's quit out of this, and we'll stop the execution, and we'll get into our camera collisions. So those are going to be pretty simple. We're just going to do all this work in update camera. So let's go ahead and find that, and it's somewhere around here. Update animation, update camera. There we go. What we are going to do is, first of all, we are going to get our player entity. So this is going to be just an entity, and it's going to be player. I'm going to name this player entity, and which is equals to, it's got a pointer to get entity. All right, so we're going to get that first. because we're going to be interested in, if you remember from our camera collisions, we were shooting a ray from the player's head, like right a little bit offset from the player's head, shooting it back maybe 1.5 to 2 meters. That depends entirely on your setup. The other thing that I wanted to do is just so that you can see where the rays are being shot from, the origin and destination. I've used some persistent debugging, so I'm just going to go ahead and do persistent debug, and actually I can just copy some of this stuff so I don't have to bore you with just typing things in. So I'm going to grab this stuff starting here maybe, and so just this stuff here. Alright, so let's see, we want to place it, where do you want to place it? Right here. So there's our persistent debug, and so for this, this is going to be, I named this camera instead of that. Let's add some text. A little bit of the text that I was using for this was to track the world position and just the world position of the player. So I was doing this for some of the debugging, but I don't think we're going to need to worry about that. That's for the purpose of this. So what I am going to do is, so I'm going to be removing these. I'm actually going to keep one of them because I'm going to need to paste it further on. Alright, so once you get down to here is where we'll be able to start bringing in some of that code. So right under this set rotation, what I'm going to do is I'm going to create a vec3, and that is target world position, and this is going to be our player entity world position. So player entity dot get world position. Alright, so this is going to hold where the player is, and we're just going to need another vec3, which is going to be our destination, so where we want to ship the ray to, and a vec3 for the origin, so where we want to shoot it from. Okay, now we get into this little bit here, because we only want to do this when it's in third player view. So I'm just gonna copy this and move it here. So if it is FPS, then all of this is what we want to have. If it's not, then we do our camera collisions. First of all, one thing that I wanted to do is I wanted to move these and place them into our header file, because these are going to get updated based on if it's third person. We're going to want to change that when it collides. So let's add those somewhere down here, so that way we don't get any issues with these not being declared or improperly declared. So we got the view offset forward equals 0.1, and this could be entirely up to you if it's it depends on how your first person character is set up, and as well with the offset up. If when it's crouching at 1.5 it's a little too high, you can adjust that. Okay, so if it's in third person, then let's get into the nitty-gritty of things. So first of all, we want to set the origin and the destination to begin with to our target world position, and we're going to offset them from there. So our destination equals target world position, and also our origin equals target world position. And now we want to offset these. We want to offset those based on, first of all, what I've done a little bit of experimenting, and it seems like it works. It works a little better if you shoot the ray from higher up and not the feet of the player. It could also work at the feet. This is entirely my experience, and while it's somewhat limited, I'm just telling you like what I've experienced. So let's type in so origin. So we're going to start offsetting this, and this is going to be offset in this way. So we have player entity, because you got to think about it this way. Just like what I was explaining before, if we offset it back a little bit, so we want that position to be rotating the same way with the player. So picture like you have maybe like a rucksack or like a backpack. When you rotate, that backpack follows you along. It's not staying on your left side or moving around to the front. So that's what we want to have here. Hopefully that kind of gives you an idea of what that is. So what are we going to do is we're going to get the world rotation of the player. And what this returns, I believe it's a quaternion. So in order for us to do an offset for this, there's a few options for that. So column 1, if we get column 1, and we'll multiply that by negative 0.2f. So what that's going to do, it's actually going to push this origin back by 20 centimeters. If I was to do positive 2f, it's going to push it forward, you know, from the player by 20 centimeters. So we have offset it towards the back of the player. Now let's offset it up a little bit. And like I said, this is also depends on your setup and the way you want to do your camera collisions. So the same thing, get world rotation, and this is going to be get column 2 to offset it up, and then we timed that by so I did it at 2 meters, so 2.0f. So that is for the origin, is where the ray is going to start from. Now we want to do the destination. So destination, it's going to be very similar, only different values. So there's that. And for that, I've actually pushed this about 0.9 meters back, because I'm going to change this camera to not be a 2, to be a little closer to the player. That's a little bit more of a third-person shooter type of game. So, and then we got destination plus equals, and this is going to be, let's see, we want to get column 2, so we want to be almost identical. So it's kind of shooting in a straight line from about the top of the player's head to 0.9 meters back. Okay, so once we have that in place, let's go ahead and this is some of the one of the things that I can't figure out if it actually works or not, but it's probably good to have. So this is going to be a static physical entity, and it's a pointer to an array of skip entities. And you can set that to 10. So these are going to be the entities that are going to be skipped by whenever this ray is being shot. So skip entities. If I could spell skip entities, and we set the 0 of that array, so the first element, to player entity dot get physics. There we go. Alright, so now we get into the meat of the thing, where we actually shoot the ray. So array underscore hit, and that is going to be called, I call this hit, which is, yeah, very intuitive. Okay, so int hits. So these are like the I'm not entirely sure why it's stored in int, but this is when the array is shot and it returns the value. So global environment variable, we get the p physical world, and from there we're going to do array world intersection. So this thing has a little bit of quite a few parameters. So one of the parameters that is going to need and that we don't have yet is going to be our direction. So let's add that in. So that's going to be a vec3 dir equals destination minus origin, because we want to shoot along that path. So within array world intersection, we're going to need a couple of things. So where do we originate from? The origin. Then we're shooting along direction. Just make a little space here. And then we want a set of flags, which are going to be all the entities that we want to account for. So I'm just going to copy and paste those in there, because they take a little bit of time to type those in. So we got static, sleeping rigid, rigid, independent, terrain, and stop it pierceable, and collision any. Alright, so there's that. And then we want the ray hit. Then 1, which I'm not entirely sure what it does. I'm thinking it's the max hits, so how many hits is going to do. Then which entities we want to skip, so we're just going to pass in our array, so p skip entities. And then 2, which I don't really know what it is that for. Just like before, I still don't know what that 2 is for. Alright, so once we have that, now we're just going to go ahead and see if we actually hit something. So if hit dot p collider, then we want to adjust the position of the camera according to where it hits something. So let's set our destination to be equal to hit.point. Alright. So what that's going to give us, our vec3 is going to be where the hit happened. But that doesn't really help us much, because in the end, if you see, we're just setting the translation to a vec3 of 0, view offset forward, and view offset up. And while we're not going to mess with view offset up just yet, we do need the view offset forward. And let's go ahead and set that. One thing that I've noticed while working with this, and I'm not sure if it's an issue with the way I've done the collisions, is that when it collides with something, the camera tends to go forward and almost, kind of collide with the player's head and go through it and then swing back. Hopefully that makes sense to you. So in order to avoid that, what I did was that if actually, first of all, let's set up view offset forward 2, and this is something that it was a little bit tricky, I would say, because the view offset forward is not like a position and sort of a sense, because right now the position of the player would be somewhere like 500 by 500 by 30. So that's what this destination is going to return. No, we want something that's just going to be the offset from the player. So in order to do that, we want to subtract the player's position, which is the target work position, dot y minus destination dot y. So this is where this view offset forward was throwing me for a loop, because it sometimes even went over 1. So the other thing that I added was this is always going to have to be behind the player. So one thing that I did was I've multiplied it -1, because it's always going to be a negative, .0f, and multiplied this this subtraction by its absolute value. So even if this is positive or negative, we're always going to set it to a negative value because we don't want to go in front of the player. So by getting to cry math, and this is a namespace, and then absolute, and placing these in parentheses. Alright, so now we have a more proper view offset forward. But that still did not really take care of the fact that it would still run into the player's head. So in order to avoid that, I did a little check to see if view offset forward is greater than, and I've put an arbitrary value here. For me, -0.03 worked just fine. So if it's getting anywhere below that value, don't get any closer to the player. So this was view offset forward. So if it is that, then I've just set it to -0.3f. Okay, so now if it does collide to something, then set it to that. If it doesn't, and it's in third person mode, then we just set the view offset forward to -1.0f, and we can also update it in here to 1.0f. Alright, so we have that, and now once we get into outside of this, then the local transform is just going to pick that value up and set its translation, and then the p-camera component will set its transform matrix to that matrix. Okay, so as you see, I've actually haven't put in any of the p persistent debugs. What I actually just had those in for was just to show you that little hot reload functionality, which I thought was pretty useful. So it was useful for me, like I said, in testing all of this. And for that, with that being said, let's go ahead and compile this and see what we get. So just going to go ahead and start up my local Windows debugger because it's pretty quick. So let's see if we close in on any of this, if we get any collisions, and nothing just yet here. And let's see, what do we have happening? Just going to exit out of this, and so one thing that we are going to put in is just to check to see if we hit something. So I'm going to go ahead and copy one of my persistent debugs here, and I'm going to place it right here. So if it thinks that it hit something, then let's show me. And also I can probably place these just to see, so you guys can get an idea of where the spheres are at. So I'm gonna paste this stuff right below here. So what I'm doing, I'm just adding a sphere at the origin and destination with different colors to them. So let's go ahead and build this. And we'll start our local Windows debugger and see what we have happening. Alright, so you'll notice that there's these two, I don't know if you can tell, there's a second green ball. Maybe when I'm rotating you can probably see it a little better. So now let's see if we're getting something here. And there we go. So you see there's a, it tells you right there, there's a hit at those values, and if it did encounter anything. So now, like, there we go. So as you can tell, it finds the hit and then it adjusts the camera. So for example, what we could do using the little thing that we added for the hot reload, we can remove those little spheres. So let's go ahead and pause this and comment these lines out. And then let's hit continue and see if this works. Like I said, for Philip, this compilation was very quick, so I'm not entirely sure if I'm missing anything. Yeah, so that's kind of interesting why that is being called as stale. But there we go. So no more of those spheres. We still get the old debug because we have that in there, but no more of the spheres where we were for our debugging purposes to see where the origin and destinations were at. So we have collisions, and of course there's these little bit where you can actually still see through the thing, and that could be probably done through a little bit of positioning the camera a little more forward when it hits something. So with that being said, hopefully that was a helpful video, and also the fact that we have this little hot reload function possibility. It's actually really useful from my perspective. So thank you guys for stopping by. Hopefully you have a great week, and I'm hoping this was helpful to you. All right, take care.